Hi guys, it currently is right after school on Monday. I just recorded this once and then the door got knocked on, so I'm starting it again. Hashtag teacher problems. And these are the notes for block day, either Wednesday or Thursday. It's going to be about vertex form of a quadratic. So please have out your notebooks and take notes on everything that I write. I warn you right now, this is going to be a little bit long, so you can take breaks as you do it, but each of these notes will help you finish the classwork and then also do the Math Excel assignment, which is going to be due Sunday at midnight. I'll say that again. The Math Excel assignment is going to be due Sunday at midnight. Okay, so have your notebooks out, be ready to go, and have fun. I miss you guys. Okay, so today is all about vertex form of a quadratic. And of course, you all already know that a quadratic means it has an x squared. So, vertex form has a formula, and it is this. Y is equal to a parentheses x minus h squared plus k, where k is the vertex.
Celeste Navarro, can you please come to the front office? Celeste Navarro, can you please come to the front office?
All right, sorry about the announcement. Okay, so here is the vertex form, and HK is the vertex. Now, if you were here yesterday in class, we actually kind of already talked about this when it came to transformations. So what we talked about was what each of these terms do to the parent function. Remember that the parent function is just the normal y equals x squared. So if you add a number, if this number k is positive, meaning like if this is a plus, we have a vertical shift up. Vertical just means up and down. And if it's a minus, we have a vertical shift down. The number inside the parentheses with the x, this is a horizontal shift. Horizontal shift, which means side by side. If it's minus, you go to the right. And if it is plus, you go to the left. It's kind of counterintuitive. It's the opposite of what you would expect. And then this thing here does a couple of things. If it's negative, what happens is the entire parabola makes a sad face. It goes upside down. So you flip it upside down. If it's greater than 1, meaning like 2, 3, 4, 5, your parabola gets skinnier. Sometimes I call that like it's squishing it. And if a is less than 1, it gets wider. Or you might want to think of it as flatter. Okay, so this is kind of review of what we did last class. Today, though, we're going to be thinking about this all in terms of the vertex, which is just these two values, h and k. Now, I know vertex form looks pretty complicated, but actually compared to standard form of a quadratic, and by standard form, you guys know is f of x is equal to ax squared plus bx plus c. Compared to standard form, vertex form actually is a lot easier to graph because it tells you the vertex, and then all you have to do is plot the points. So I want to show you an example of how we can graph this, or rather, I want to show you an example of why hk is the vertex. So as an example, I'm going to use what we learned last class. Let's graph y is equal to, I won't put an a because that just complicates things, but I'm going to have x minus 3 squared plus 1. We're going to graph that on this graph here. I'm going to go over 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so let's review what we learned last class. This plus 1, it's plus, so we're going up 1, and this negative 3 is a negative, so go here. Negative means go right, so we're going 3 right. So we would start with our parent parabola, which just looks like this. We have 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. There's a poster in the class on the right side of the class that has all these points on there. This is the parent parabola. That's the normal one. And we're going to move everything 3 to the right and up 1. So we're going to move every single point 3 to the right. 1, 2, 3, up 1. We're going to move this point 1, 2, 3 to the right, up 1. And what we'll have is 2, 1, 2, 3, 4, our own little parabola here. And it's been shifted up 1, 3 to the right, like this, transformation. So another way to think about it is actually we can identify the vertex. If you look here, this point is our vertex, which is the x is 1, 2, 3, and the y is, oops, I spelled that wrong, and the y is 1. Well, where do you see those values? Where did you see them before? Well, that's just this value and this value here. Now, if you notice, the 1 is positive in both places. That makes sense because you're moving up 1, you're moving up 1. And the sign here actually changes because since this means 3 to the right, the negative means 3 to the right, here your vertex is going to have the opposite sign. So that's where it comes from in the formula. X minus h, you're moving right h many, which means the x coordinate of the vertex is just this number. And you're moving up or down this number, which is the y coordinate of the vertex. I know it maybe doesn't sound that fun, but it actually is pretty helpful. Just as another example, I won't make you graph them, but just I want you to be able to identify the vertex easily from the equation. So some other examples. All I want you to do is identify the vertex. So here, let's say we had f of x is equal to 2 times x, I don't know, minus 7 squared plus 3. Okay, so the vertex is h comma k. So you got to think about what the formula is doing here. You have a parentheses x minus h squared plus k. So the h here is plain old 7 because it's just minus h minus 7. You don't, the 7 here is actually going to be positive. I like to think about it as flipping the sign. So if it's a negative in here, the x is going to be positive. And then the y is the k, which is 3. That would be the vertex. And then you don't even have to worry about this number because that just means it would be twice as skinny going up. As another example with some different signs, f of x is equal to, I don't know, 1/4 x plus 3 squared minus 5. Here, the vertex h comma k. So if you think about this as a x minus h squared plus k. Okay, well, the h, let's see, you could think of it as just flipping the sign, so it's going to be negative. But the reason why is that what would we put here as h to make it a positive 3? Well, h would have to be negative 3. So the x is negative 3. And the k, well, the k is just this number, negative 5. Just like that. I think that is all for this part of the notes. You can actually take out your classwork and I'll show you some other things on there. So take out your classwork that looks like this. And I'm going to do the first one with you. Maybe the first and the second. So, okay, this is all about the vertex form. You could do this with transformations, but we're going to do it using the vertex form. Zoom in here. Okay, number 1. So, the vertex. You switch the sign of this, so it's 3, comma, 2. Easy. Let's graph it. 1, 2, 3, 1, 2. This is the vertex. Okay? The next question says, does it open up or does it open down? Well, let's think about the equation. If there were a negative here, it would be an upside down parabola, but there's not. So it's a happy parabola, which means it's opening up. So I know it's gonna go this way. In fact, I actually already know what it's gonna look like since there is no A. It's not squished or spread out. So it's gonna have the normal numbers 1, 1, 2, 4, 3, 9. So I'm gonna go over 1, up 1, over 2, up 1, 2, 3, 4. For 2, up 1, 2, 3, 4, like this. So my parabola actually is just right here. So then the question asks me, is it a maximum or a minimum, the vertex? Well, is this point the highest point or the lowest point? The vertex is a, let's see, it's at the bottom, so it's a minimum. So this is a minimum. And then the axis of symmetry is just the line, it's the mirror line that goes right through this thing. So the axis of symmetry goes right through x equals 3. You'll notice it's the same number as where the vertex is. It's pretty easy. Okay, domain and range are two words that you probably learned in Algebra 1, but I'm going to review it here because it comes up on your Math Excel. So the domain is the possible x values. So if you think about this equation, is there any x value you're... Oh, hold on.
Basketball tryouts are at the gym right now. Basketball tryouts are at the gym right now. Si quieren jugar basketball, las eliminatorias son ahorita en el gimnasio.
Okay, so it's the possible x values. If you look at this equation, you could plug anything in you wanted for x. I actually like to look at the graph. If you think about these arrows extend forever this way and forever that way. So the domain is actually all real numbers. Or said another way, it goes from negative infinity in this direction, goes all the way to negative infinity, all the way to positive infinity. Like that. Now the range is the possible y values. Okay, this one's a little bit different. If you look at our graph here, the parabola can't be less than where y is equal to 2. Like all this stuff down here, there is no parabola. So y actually has to be greater or equal to 2. So there's two ways we can write this. We can write y is greater than or equal to 2, or we can write y could equal to or go to infinity. It's in between 2 and infinity. The bracket here means it could equal to. We use a parentheses with infinity because it could never actually equal infinity, because infinity is an abstract concept. Okay? I know that's a little tricky, so I'm going to do another one. Let's do number 2 here. So number 2, the vertex, we switch the sign of this, so it's -4, comma, -2. That's the easy part. -4, -2. Okay, does it open up or down? Well, do you see this negative here? That means we're going to flip it. So it's going to be an upside down parabola. So it's going to be opening down. This one also goes 1, 1, 1, 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4. So here is the vertex a maximum or a minimum? Well, it's at the top, so it's a maximum. Now, as for the axis of symmetry, that's just this line here, which is x is equal to, let's see, what's that point? -4. It's also the same thing as the vertex. Now the domain, well, the domain for all of these is going to be all real numbers. X could equal anything. X can go all the way positive, all the way negative. That's what these arrows mean. So I could either write all real numbers like I did over here, or I can write -infinity all the way to infinity. For the range, okay, y can't equal anything up here. The only things y can be are -2 or less. So I can write this a couple of ways. I can say y is less than or equal to -2, Or I could say that the lowest thing y is allowed to be is negative infinity, and the biggest thing it's allowed to be is negative 2. Okay, I know the domains and range stuff is tricky. We can talk more about that when I get back. I think there's only one problem like that on your Math Excel. But this, and this should be pretty straightforward for you. So I want you to pause the video right now and actually finish this side of your worksheet. Don't go on to the back yet. So pause your video and finish this. Yay! Okay, welcome back. Before you start this part, please make sure that everybody in your group has the same answers to the front of the classwork. The back of the classwork has you convert from standard form of a quadratic to vertex form. So let's remind ourselves what these things are. Standard form is when you have y is equal to ax squared plus bx plus c. Vertex form is when it's in the form y is equal to a times x minus h squared plus k. The cool thing about vertex form is it tells you the vertex. Standard form tells you not that much. So I'll give you one example. And we are going to convert f of x is equal to x squared plus 6x plus 3 into vertex form. Now, how are we going to do this? Well, you already know. We get to complete the square. Yay! So we're going to complete the square. So how do we do this? Well, instead of f of x, I'm going to write this as y because f of x is going to be too confusing. So I'm going to write y is equal to x squared plus 6x plus 3. Now, we want to get this into this form here. So we need to somehow have the square of a binomial. Well, that's going to come from this stuff. So I don't want the 3 in my way. I'm going to move it to the other side. So I'm going to subtract 3. So what I have is y take away 3 is equal to x squared plus 6x. Okay? Now I'm going to complete the square. How do I do that? I'm going to add b over 2 squared to both sides. My b is 6, so I have 6 over 2 squared, which is 3 squared, which is 9. So I'm going to add 9 to both sides. It looks like this. Let's see, I have y take away 3 plus 9 is equal to x squared plus 6x plus 9. And that 9 just came from right here. Now what I do is I can simplify this. So I have y plus 6 equals, and I can write this as the square of a binomial. So it's x plus something squared. What is that something? Well, it's half of 6, or you can think of it as the square root of 9. So there you go. Okay, one more step to make this look like this. Well, here we have y alone. Here we don't. So you got to move it back over. Minus 6, minus 6. So my final answer is y is equal to x plus 3 squared minus 6. My vertex would be what? The opposite of this, negative 3. The same as that, negative 6. Ta-da! Okay, now pause the video and do the back of the classwork. Hey, welcome back. There's one more thing I'm going to teach you while I'm not even here. And it is how to write an equation in vertex form if you're given the vertex and any other point on the parabola. So in theory, I can give you the vertex and literally any other point, and you should be able to write the equation in vertex form. Now let's remember what vertex form is. Hopefully you're memorizing it. Y is equal to a parentheses x minus h squared plus k. And I'll give you one example. Now this stuff is going to help you on the Math Excel assignment. There's nothing on your classwork like this, but there's some problems on your homework. So I wanted you to have seen an example. So let's write a student example. Write an equation in vertex form that has a vertex of 3, 4, and the point 112 is on the parabola. Now, one thing you could do is you could literally graph this. I don't recommend it, but you could literally make yourself a graph and be like, okay, I know that 112 is on my graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the point 112. And then the vertex is 3, 4. So I need to go over 1, 2, 3. And I'd have 1, 2, 3, 4. So you actually already know that your parabola is going to look like this. You could totally graph this and then figure out the equation from here. You would know the vertex. So the only thing you need to figure out is it squished or not? And it kind of looks like it is pretty skinny. So here's what I mean. So graphing it, you could figure it out. The way I'm going to show you is the algebra way. So the first thing I do is I write vertex form. Y is equal to a x minus h squared plus k. So I already know my vertex. This is my h, k. So I can plug that in, which means I have y is equal to a x minus h, so x minus 3 squared plus my k is 4. So that's my vertex. How am I going to figure out the a? How am I going to figure out if it's squished or not? Well, I actually also have a point, x, y. This is the point x, comma, y. So I can plug that in for x, y. That's what I'm going to do in the next step. So y is equal to 12 is equal to, a is the one thing I still don't know. But I know that x is equal to 1. And I'm still going to do minus 3 squared plus 4. Okay, now I know that looks gorgeous, but you can solve this because this is a single equation solving for a variable. You guys know how to do this. This is pretty straightforward. I'm just going to simplify. So I have my two sides of the equation. I have 12 is equal to, a is the one thing I don't know. Well, what's 1 take away 3? 1 minus 3, that's negative 2 squared plus 4. Okay, I can keep solving. Think PEMDAS. What would you do next? You would do the exponent, right? Negative 2 squared, negative 2 times negative 2, that's 4. So I have 12 is equal to a times 4 plus 4. Now this is really the same thing as 12 is equal to 4a plus 4. I just switched the order here. And now this is easy. You have your a, you're looking for it. What are you going to do both sides? Well, you're going to subtract 4. So you have 8 is equal to 4a. Divide by 4. And you have a is equal to 2. Ta-da! So your equation, your final answer, is that, let's see, we start with our regular vertex form. Y is equal to, y is equal to a parentheses x minus h squared plus k. And now you know what a is. So y is equal to 2 parentheses x minus, well, we know my vertex, the x is 3 squared plus, what's my k? My k is 4, and that's it. And that actually makes sense if you come back up and look at what my graph was, because if you look at that graph, it does look like it's twice as skinny. So if I zoomed in here, and if I had done a better job graphing this, you could have actually really been able to tell that this is, okay, from 3 to 1, I'm going over 2, but I'm going up 8. Well, that's twice as much as you do in the normal parabola. So that's it. Okay, you should be good to go to start your Math Excel. Have fun. Yay, math.